Activity 11.23 is spelling volume. And for this one, we actually need some of these shapes. And these are from EPA Hand 9 and they're called relational geosolids. What we're going to do is compare volume of different shapes to develop volume formulas. The very first questions asking compare the volume of a cube with the large square prism. I'm going to show you that these are designed so they have the exact same bases. They also have these little circle holes in them, which I took out so you can fill them up. So what we do is we take off the bases. Again, I'll show you that these are identical. That's important. So we have our cube. And then we would have our square pyramid. I'm going to fill those with water in attempt to because I want to know how many times I can fill up the cube with the square pyramid. So I have the water here. Here is my cube. Here is my square pyramid. Four. Now I'm going to go in there one time. A little bit better. Much better. Let's do it. Almost to the top, thinking about the lips that perfect space. Next question is the large angular prism, the large angular pyramid. Same height, same base. So I'll take off the bases again and show you these two are congruent. They are the same. I want to know how many times I can fill up the triangular prism with the triangular pyramid. So let's do some more pouring. One. Two. One. I could fill 3 times roughly, running the whole number with the square pyramid filled up the cube and the triangular pyramid filled up the large triangular prism 3 times. The conclusion is then that a pyramid with the same base and height as the prism, the pyramid would then have 1/3 of its volume. Then we're going to go to the next question, C. We're going to fill up the cylinder with the cone. Diamond cylinder and I have my cone. They have the same base at the top and top. I can show you that these two circles are congruent. They have the same base. They also have the same. Flip it over. I'm going to fill in my cylinder with the volume of one time. Also is 3 times. So a cone with the same base and height as the cylinder have 1/3 of its volume. Or D, it is sphere with a cone. So let's go ahead and find out. Okay, I have my cone and the sphere. So there is a little hole up here where I can fill the cone into the sphere. I can also take this cone apart, sorry, the sphere apart I can see that they have the same circle, so the cross section of the sphere and the base of the cone are going to be the same. So try to do is fill up my cone and see how much will fill into the sphere. So here is my sphere. It's exactly very tiny. Okay, so if the sphere with the cone, half the sphere with the cone, so that means the cone would have fit two times, once and half the hemisphere, and then a second time on the other half, so two times. So the if the cone has two times the radius that the sphere has, then it is going to be, oh yes, the height. Let me show you that. But the height of the cone on the sphere, the radius, um, two times the radius of the sphere is the height of the cone. So then it has half of its volume. So let's put this all together. We already saw that a prism, which was the area of the base, times the height. So E is an area formula. The pyramid would then be 1/3 base times height. The area of a cylinder would then be the area of the base pi r squared times the height of the cylinder. The cone was 1/3 the area of the base times the height. And then the sphere would be 2/3, or 2 times 1/3 pi r squared times the height, but except that the height of the cone was 2 times the radius. So now I'm going to get 2/3 pi r squared times 2r. I can simplify that more because 2 times 2 would be 4, and then thirds, and then I get pi r squared times r is r cubed. So the volume formula for a sphere is then 4/3 pi r cubed. Prism area of the base E is going to be an area formula, depends on the shape of your base, which is the same, by the way, for the pyramid. And that capital H is always going to be the height of your 3D shape, whether that's a prism, a pyramid, a cylinder, or a cone. So keep this table handy for when we're going to find the volume of different shapes.